ever asked ChatGPT a question about your document and it got the answer completely wrong? Well, the reason it got the answer wrong is because it does not know your document. So in this video, I'm going to show you how to build a RAG system, also known as a Retrieval-Augmented Generation system that is focused on your specific documents, and the answers will never be wrong. So in the next 15 to 20 minutes, we are going to be building this, and we will be building it with free tools that is accessible to anyone like Qdrant, Docling, and Gemma. So if you love content around AI, Python, do well to hit the like button, and let's get to building this awesome tool. In case you don't know what Qdrant is, it's a vector database that makes vector similarity search easy, and it's, according to them, it's a platform where AI meets advanced vector search. All the links to the tools used in this guide would be added to the video description, so you can click so you can check that to create an account on these tools. So this is one of the tools I will be using, and next we will be using Docling. And Docling is a platform that simplifies document processing, so it lets you process PDFs, doc files, HTML files, and other document file types. And lastly, we would also be using the Google Generative AI Python package that will give us access to using Gemma 3. And if you want to generate your own Gemini API key, you can head over to Google AI Studio, sign in, and then you can generate your own API key. All right, so now that we've already gone through the tools that we would be using for this guide, let's start building our application. Okay, so first let's start by installing the tools. So we'll start by installing Qdrant clients, Docling, fast embedded, Google Generative AI, just so that I'm using the correct one. We can copy it here and paste it on our terminal. So these are the necessary tools that we are using. So I'm going to skip till the end of the installation package. Okay, and now that we have installed all our needed libraries, the next thing to do is to import them. Please ensure that when you are building this in Python, ensure that you install the packages or the libraries that you will be using in your virtual environment. Okay, so if you look at the project structure, you would see documents here, which has the document, and this document is a lecture note on fishery and wildlife in agriculture, and then app.py would be our main logic. So what we'll have to start importing the library. So we'll start with Qdrant, and from Qdrant we are going to import Qdrant. From Qdrant client we are going to import Qdrant and models. Then from Docling we are going to import the doc converter from the doc converter function, and then we would import some other things. Okay, so these are the packages and tools that we would be using Qdrant, Docling, Fast Embedded, and the Google Generative AI package. Now, in case I forgot to mention, Fast Embedded is a lightweight Python library that is built for handling embedded stuffs. So I think that this I think that Fast Embedded was built by Qdrant because a lot of documentation I've read about it has to do relates to Qdrant. So in essence, Fast Embedded is what you use when you are performing any text embedding function or method in your project. And document converter here that we are importing from Docling is used for reading and converting documents like PDF, .docs, .txt, literally any document file type is used to convert it to a structured format. So the whole aim of this project or building a RAG system is so that your document is being converted to smaller bits or manageable pieces called chunks, and the response gotten from your AI model would be better because your model would be reading your documents as chunks instead of reading it as a whole document. Okay, so after this we would have to define our source, that's our source document. And remember I said that I added a PDF in our documents folder, so all I just have to do is to add it here. So say documents. Okay, so I would have to rename this to fishy. Okay, so it will be document fishy.pdf, and this will be the source of our documents. And after we have defined the source, we would have to convert it to a structured format for our RAG system or for Gemma to interact with it. So we'll just say documents equals to, using the document converter dot convert, and then we'll have to define the source dot document. So this line should handle the conversion of the document to a structured format. So we can print this and see how it looks. So yeah, we can print this and see what the output looks like. Okay, so this is how the conversion looks like. So it just has my the information on the documentation that has been converted into a structured format. Right now this looks like gibberish that you may not understand, but I just wanted to show you how this looks. So we can comment this part out and continue building. So next is we want to process these documents. Now this document that has been converted to a format, we want to process them into smaller pieces or smaller chunks. Okay, and then we also want to ensure that these chunks, they do not exceed a limit of, let's say, 200 token on all mini LLM v2 model that is found under Qdrant. Chunk tokenization. We're going to define a variable called chunker, and this chunker would use the hybrid chunker found here. Chunker, I need to have, tokenizer equals to this. And then we will define the chunks. So it's going to be chunker dot chunk and then a maximum token. Remember we said a maximum token of 200. You can decide to expand your own to 256 or 512 or whatever maximum token that you want to define it. Okay, now let me explain what this does a bit more. So this line 12 where we are doing the chunk tokenization. Okay, so we are using a tokenization model called the sentence transformer mini LM, which is very, very lightweight for this type of project. And what this transformer model does is that it's good at understanding the semantic meaning of the text. So the text found in the documents here, that's what this tokenization model is handling. And then the next line where we are using the hybrid chunker, so it's an instance from Docling chunking library, and it's used to combine different chunking strategy, like the sentence based and the token based, to create meaningful text segments. So it's used to break up the text within the documents much more better. Okay, so what this last line does is that it's a chunking operation that is performed on these documents that we have defined in our project directory with a maximum token of 200 tokens per chunk. So every time we chunk our documents, like we break them into smaller segment or smaller parts, each part would have a maximum token of 200. So we can decide, let's increase it to 300. So each token would have a maximum token of 300, and the chunk method is likely used to process the documents and return the segments. So this type of chunking operation, though I am very, very new to this, but this type is mostly used for text summarization in a RAG system. Okay, so now that we have performed the chunk operation or the tokenization operation, what we want to do next is to take each element from the list of this chunk. Okay, so we want to take each element and extract the text attribute in that chunk and use that attribute to build a new list that contains the text from each of the chunks. So how we are going to do that is we have to define another variable called text chunks, and to be a list. So this is how you define a list in Python, and we can say c.text for C in chunks, and then we can print this text chunk to know the length of the text chunk. Okay, so we got this error, and I think that this error is coming from PyTorch and our memory, and so that the error stops showing, I would have to add this line, run this again, and I'm very sure that the error should stop showing. Okay, and the error stopped showing, and it also tells us that the length of the text attributes, the length of the text chunks is 21. So let's comment this out, and continue building our projects. Okay, so next up, let's use the text chunk in our embedded model. That's this text embedding from fast embedded. What we're going to do next is embedding model equals to text model, and the model name that we would be using would be the BAAI model. Let me explain what this line does. Okay, so what it does is that the embedding model uses the text embedding instance found from the fast embedded library, and it uses the BAAI embedding model, which is a very lightweight model, very good for this type of project. And this model too, it's also used for English texts. I think there are definitely other models for other languages, but this PDF is written in English. So that's what this does. So this is just defining the embedding model. Then the next line, which is the embeddings, what the next line does is it generates the embeddings for this text chunk that we created in line 19. Okay, so now that we've figured out, or rather now that we are done with the embedding, the next thing that we need to do would be to create our Qdrant clients and make use of that. So we have to call the Qdrant clients that we imported from the Qdrant clients package, and inside the Qdrant clients we would be defining memory, and then we'll need to define a collection name. Collection name will be fishy collection, since the book is about fishery and wildlife, or we can decide to name it wildlife collection. Okay, and once we have defined the collection name, the next thing would be to create the collection. So to create the collection, we would need an embedding, what we call an embedding dim, that will take the length of the embedding, this embedding that we defined earlier, and it's going to use that and some other information to create the collection that we need on Qdrant. So we are going to do clients.create collection, and we will need the collection name, which we have defined here already. And after the collection name, we'll need the vector configuration, because remember, Qdrant is a vector database, and RAG system would also need vector search to really give us an accurate answer or response to our question. So we need to do the vector config. Okay, let me go over this code one more time after we have created our Qdrant client. Okay, so this line create an in-memory temporal database of the Qdrant clients that we will be using for the vector search, since this project is running locally. But if you would want it to if you want to create a vector database on cloud, you can head over to Qdrant and sign up and create the vector database. The link to do that, I will be including that in the video description. But this line creates an in-memory temporal vector database. And then this is to create the collection name for our vector database. And this next line is used to figure out the length of our vector database. It's also used to determine the dimensionality of the embedding vectors that we would be using in this project. And the reason is because all vectors in a collection must have the same dimension length, and this helps us check that. Now, this line from line 29 to line 36 is used to create our collection, and as you see, it takes in the collection name and it takes in the vector configuration. Now, in the vector configuration, it takes in the parameters like the size of the vector, which is this, because remember I said that all vector must have the same dimension size, and it takes in the distance, and the distance is mostly used when it comes to similarity for comparing vectors. Now, I really do not have a lot of ideas when it comes to machine learning, but this is the little I know when it comes to playing around with vector database and how to create one, especially on Qdrant. Now, after we've created our collection for the in-memory Qdrant vector database, the next is this points configuration. Now, what this points configuration does is that in this points structs, it's a function that is taking the ID, which is a unique identifier of the index of the embedding. Then it takes the vector, which is the actual embedding vector, and it's taking the payload as well. Now, this payload is an additional metadata that contains the original text chunk, this text chunk here. So that's what we are adding to our payload. And what this for loop does is that it's looping through the embeddings to keep track of the vectors that are in the embeddings. So next up, we want to upload these points and the collection, or the collection name, to our Qdrant database, and then we would pass a test query to test if our Qdrant database has been set up correctly and if we can interact with the chunks and the embeddings in the vector. Okay, so let me explain the following code. So this part that I said is to upload the point is actually for Qdrant to perform the vector similarity search using the collection name and the point. Then as for this query, now this query is we want to know what the main topic of the document is all about, this document that we have defined here. And then this query vector, it converts this question, the question that we've asked in the query text, it converts the question into a vector embedding, and it uses the same model that we use for the document chunks, which is this model. So it uses this model to convert the question into a vector embedding, and then takes only the first vector since the embedding is a single question. This ensures that it takes only the first vector since the embedding is only a single question. Then this search results part, what the search results handles is the similarity search. So it queries the Qdrant collection for 3 most similar search. That's this limit that you've set here would query for 3 most similar search. You can decide to expand yours to 5, 10 or 2, it depends on you. Okay, and then and what we added here is we want to print the search results. We want to see what it looks like. Actually it's going to look like more like an ID, a version, and a score. So when we run that, we should be able to see. Let's just run it. Oh yes, we made a mistake here. So looks like it was supposed to be vectors, not vector. So let's change that and let's run our application again. So I had to comment out this context part because I just wanted to only see the search results. When I explain the context part, I will uncomment it so that you can see everything. And there you have it. You've seen the ID, we've seen the version, we've seen the score. The score is the score of the embeddings, and we've seen the payload, which shows the academic session, some other information like vector shard key. Okay, and yes, and we've been able to see the output. Now remember I said that this limit 3 is that we are looking for the 3 most similar vector results, and we are going to be printing it out, and that's what we got here. So this first part is the first result that told us the academic session. The second part, which is here, it gave us information on the reference textbooks of the documents. And the third part, which is this part, it gave us the niche, like the niche of the document, and it also includes the ID, the version, and the score. Now if you look at the scores are somehow similar. So this is how we handle the retrieval of the information. Now let's talk about this context. Okay, so what this context does is that it's extracting the original text from each of the matching points payload. So this payload now, that's this payload, the payload in the 3 most similar vector search or vector embedding, it's going to extract the original text from each of the payload, join all the text chunks together with a double line. This is how you can define a double line in Python. So it joins all the text chunks together in a double line, and then it creates a context for the most relevant chunk. This part, it creates a context for the most relevant chunk. So if we uncomment this out, that's we uncomment the search results, we comment the search results and we uncomment the context, we should have one response because it's joining everything together. And you've seen it. So it joined the context, the academic session, the references on the textbook, the lecturer in charge of the notes, and what the topic in the document is really all about. So it took these chunks now from the payload. When we did this, when we printed out the search results, it took all the text from there, joined them together with double lines, and then it gave us the output. So this is how we can do the retrieval part of the RAG system. Okay, so now let's do the generation parts using Gemma and Gemini API key. So I added my API key in my .env file so I can easily import it. I don't think I have python.env installed, so I would just install that real quick, and I do have that installed. So since I have that installed, I just have to do is I can do from python.env load env, and then I'll have to load this. So this should help me handle my secret information that I added in my .env file. Okay, so let's configure our Gemini. Okay, so we're going to use a gen ai.configure. It's gonna ask for the API key. So this is what I named my API key, Gemini API. Okay, so after we have defined our API key, next we'll need to define the model. So remember I said that we are using the Gemma model. So I made a mistake. It's actually from .env, not from python.env. So from .env I can use this. Okay, so now that we have configured our Gemma, and we can now do the we can now do the generation part, since we have already covered the retrieval part of the RAG system. We need to define a prompt. So now this is a lesson note. So my prompt would be you are a student, you are a college student studying for an upcoming exam. Of course your prompts can be better. So yeah, so your prompts can be better. So you are a student, or you're a college professor who specializes in wildlife conservation. Use the following context to answer the question. The context would be this context here. Then the question would be this query text. Okay, and then I want the answer. Okay, then we need to close our f string. So this is the prompt here: college professor specializing in wildlife conservation. Use the following context to answer the question. So it gives it the context and then the question, and then the answer would come up. So after this we'll need to define we need to get the response from Gemma. We're going to do model.generate.content. Contents these prompts, and then we want to print it out. .txt. So we want to print only the text part of the response, because the response has so many other data alongside the text. Okay, so I'm looking at this code now and I feel like it could be better. So how about we add this part that has to do with embedding the query, the interaction with the Gemma model, so we can update it to a function. Okay, okay, so we've converted it to a function that takes the query text, the clients, the collection name, the embedded model, and the limited similarity search as parameter. So it's literally the same thing, but just converted it to a function to make it really easy for us. Okay, so since this is a CLI project, okay, let's call our function. So then the results equals to Qdrant Now, since this is a CLI RAG system, I would love to take in the user input. So I can decide to say user query. I need to be inputs. Enter your question about the documents. This user query, clients, collection, the embedding, right? The collection name, the embedding, yeah, the embedding model, and then we can print the AI response. So let's test this updated function and taking the user query from the terminal. So projects. Okay, so I can ask what is the document about. Yeah, it looks like I was not supposed to add the model in front of this, so just checked the documentation. So I removed the model, trying it again. Hopefully it works this time around. Let's ask the same question. What is the document all about? And then it gave me the response. So it says that this document is a syllabus or an introductory statement from a professor for a wildlife conservation course, and the section focuses on fish ecology offered for 2024 and 2025 academic session. And he also gave me more detailed about what the document is really all about. So this is how you can build a retrieval-augmented generation system that uses Qdrant to store your documents, breaks them down into smaller parts called chunks, and Qdrant would handle the retrieval part of your RAG system. Then it retrieves that information and sends it to Gemma, which we used in this case. We used Gemma 3. So it sends it to Gemma, and Gemma would give a more concise response. So This is how you can build your own RAG system, and there are so many use cases for RAG. You can use it to study, you can use it to build an AI chatbot, and you can use it to do so many other things. So if you found this video helpful, if you really liked the step-by-step breakdown guide of this video, do well to share with someone that is currently learning AI or RAG stuff or Python. Leave a comment, like, and please subscribe so that I can keep making such videos like this. So I can keep making videos like this and keep sharing what I know in Python with every single one of you. So thank you for watching. As I said earlier, if I've also made any mistakes in this video, please do also leave a comment and let me know. I learn every day. Until the next video, do have a nice day. Happy coding. Ciao.